Now that we are done with valence electrons, you guys, valence electrons, those were the last couple slides. So we started here and we talked about those, barely touched that last slide, which is okay. And now I want to go back to the beginning and we'll start talking about chemical bonds now that we have a little bit in our heads about those valence electrons. So in terms of bonds, why do atoms want to form bonds? And by that, what we mean is, when I look at my periodic table, so all of these atoms are looking for partners. That outer energy level, they want it to be full of electrons. And for most elements, full means 8 electrons. So if I look at something, I'll pick on fluorine. Fluorine is one of the most reactive elements. Fluorine has 7 valence electrons, so fluorine needs 1 electron. So in terms of becoming stable, fluorine's trying to gain an electron in order to get to that magical number of 8. If I look at something like arsenic, there's arsenic. Arsenic has 5, so arsenic needs 3 more. It currently has 5, it needs 3 more to get to that magical number of 8. If we look at some different elements, over here, magnesium, this one's a little different. Magnesium has 2. Magnesium wants to lose 2 electrons. Oh, and I should add here electrons. We're talking electrons here. Magnesium wants to lose 2 electrons to get to that magical number of 8. Something like potassium. Potassium wants to lose 1 electron to get to that magical number of 8. So as we're looking at this idea of stable, all of the elements on the periodic table are looking to either gain or lose electrons to become stable, with the exception of the noble gases. The noble gases, if you notice, already have 8 electrons. Their atomic energy levels are already full. Now we do have an exception here. Helium only has 1 energy level. And if you remember energy levels, the first energy level, 2 electrons maximum. And so helium has that first energy level. It already has 2 electrons. So helium is full at 2, but what that means is its outer energy level is full. Helium doesn't want to react with anything. It's already full. The others already have 8 valence electrons. And so since they already have 8 valence electrons, those are called the noble gases because they don't react with anything. Outside of that group 8, every other element on the periodic table is looking to gain or lose electrons in order to become stable. And that's why elements are always forming bonds with other things. It's that attempt to become stable. So stable full outer energy level, that's what it means to be stable. Most of them want 8. So that's a magical number we're going to start using. Exceptions right here. Helium and hydrogen, because they only have that first energy level, they are looking for 2, and that makes them full. So the key is they want to be full, and most elements it's 8, and there are just a couple that are looking for 2. The ways that they become stable, well, first method right here, you're a noble gas, you're already stable, you have a full outer energy level. But then we're going to look at atoms gaining electrons, atoms losing electrons, atoms sharing electrons. Those are the 3 ways that atoms can have a full outer energy level. So in these attempts to become stable, if atoms are shared, if atoms are gained or lost, that forms a chemical bond. It's a form of attraction. So When electrons are shared, when electrons are gained or lost, now there's a force of attraction between atoms, and they are actually bonded together. I compare that in the human world if two people are dating. That's kind of a bond. There's an attraction there. Those two people are now together. And that's kind of what happens with elements. No, elements are not human. They don't date each other. But the idea is, well, if I gave an electron to a different element, well, now there's a force of attraction and we're now held together. And so we see two types of bonds. The first type of bond is in an ionic bond. There's no sharing of electrons. So in this case, sodium gives an electron to chlorine, and they don't share the electron. Sodium gives it up, chlorine takes it, and they're now bonded together. Covalent bonds, if you look, this one's a little different. The electrons are shared, and if we look, that hydrogen and carbon are sharing an electron. Carbon is sharing an electron with that hydrogen. Carbon is sharing an electron with that hydrogen. And carbon is sharing an electron with that hydrogen. And so the two different types of bonds, and we'll take a closer look as we go. Ionic bonds don't share the electrons, and covalent bonds do. And so then we've seen formulas, and you've seen these before. We write the symbol, capital H equals hydrogen, capital O equals oxygen, and then we use subscripts. This tells us the quantity. And so in terms of subscripts, H2O, there's 2 hydrogen. We don't ever write the one that's actually there. There's 1 oxygen, but we don't write that one. We just assume that it's there. Just like in math class, when you see X, it's understood that the number 1 is out in front of X, that it's 1X, but in math class, we don't ever write the 1. Well, in chemistry, we don't ever write that one either. And so here, 6 carbons, 12 hydrogens, 6 oxygens, 2 oxygens. No subscript, so that means 1 Na, Na is sodium. No subscript, 1 Cl, 1 chlorine. Oops. Oh, there we go. Oh, I'm not sure why it's doing that to me. Yikes. I'm just trying to erase here and it doesn't seem to want to cooperate. There we go. And so now we've got no subscript, so there's 1 carbon, 2 oxygen. So when we see those subscripts, it applies to the element in front. And remember, we just don't ever write the ones. So the formulas, there's our shorthand method of writing the chemical formulas. Longhand would look something like this. We would never want to do that. It's just too long. 2 parts oxygen, 1 part, or 2 parts hydrogen, 1 part oxygen. We want to do right here, we want that shorthand, that formula. And so we see the letters of the elements involved. We see the subscripts. Remember, we don't write the ones. In chemistry, we never write the ones. Just like in math class, we never put the 1 in front of X. We never put a 1. If I see this formula, this is carbon monoxide. Well, that tells me 1 carbon, 1 oxygen. This is carbon dioxide. We just saw that one a moment ago. 1 carbon, 2 oxygens. And so that's how our formulas work. And so again, these elements are combining together in an attempt to become stable. They want that full outer energy level. And so that's where compounds come from. They're looking to gain or lose electrons in order to fill their outer energy levels, except the noble gases. Because those noble gases like helium are already full. And so noble gases don't need to combine with any other elements.